Okay, welcome to the fourth talk in the Business and Energy series of Forum 2100. My name is David Gauci, and on behalf of both Dave Nagel and me, I welcome you to our session. Just some quick ground rules. Please be sure your audio is on mute. We shall run the session as efficiently as possible with a presentation of 18 minutes duration, followed by 10 minutes of questions and answers. The topic today, blockchain and energy, and the presenter, Anna Trbovich, COO of Grid Singularity, have attracted quite a bit of interest. There are attendees from China, India, all over Europe and North America, and we are especially pleased to welcome attendees from Africa and from South America as well. Anna Trbovich will present blockchain in energy with a focus on use cases and the Energy Web Foundation. Anna has had a remarkably interesting career in key positions in public service, in the academic world, and in business. Please view her bio that is posted on our website, www.forum2100.org. Anna, welcome to Forum 2100. The floor is yours.
Thank you, David, and happy to join the community today as a speaker and hope that it will be interactive. I will cover a range of topics and leave areas for Q&A so we have time to discuss some of the topics in more detail. I will also aim to finish before my 18-minute limit if possible. I hope that everyone can see the presentation. If not, please alert me. The topic today is the energy blockchain, which is an open source public platform for blockchain applications, blockchain-based applications in the energy sector. And it's built by the Energy Web Foundation, which is a nonprofit organization registered in Switzerland. And has a number of energy corporates and startups already as part of its ecosystem, as you will hear a little later. So I will cover 4 topics: why blockchain and energy, what are some of the evolving applications, what do we do at EWF exactly, and why it may be interesting for some of you to join our work in one form or another. So firstly, I would just like to remind everyone, although blockchain has almost become a household name today, or at least a hip topic to discuss, it is a technology that has features that are interesting to a range of industries, energy included. Its immutability and authenticity provide a much higher level of trust of the data that is generated and distributed and used in transactions. There is no single point of failure as it is a distributed platform and not on one single server or silos. You can trace what is happening. It is very transparent. It can still enable privacy through a feature called secret store or another feature depending on the blockchain used. And it is a very important feature for data privacy in industry, energy included. Smart contracts are not necessarily contracts, so they could be contracts. And they are algorithms that say if A does this and B does that, then C happens. And those could be very simple algorithms or more complex. And it is a way to automate processes. And that is very important for simplification of how business is done. So in energy specifically, we have applications that are at the distribution edge where blockchain becomes especially interesting because it can aggregate a number of smaller actors in a much less expensive way than done today. Especially in using renewables, distributed resources, this is very important if you want to get to a cleaner, decarbonized energy use. Again, happy to talk more in the Q&A session or when we get to actual applications. So far, there have been a number of surveys as to what are the interesting applications in the energy sector that are based on blockchain. And this is a survey done by a business school in Germany, SMT in Berlin, and Dana, which is the German energy agency, which surveyed energy sector executives. And they discovered that most interest was in transactive and P2P trading applications, as well as distributed generation, followed by maybe on the face of it, less interesting, but very useful applications that are back office automation applications that could sharply reduce costs, increase transparency, and just better use of one's energy data. And that study was from 2 years ago. This April, we had a large annual conference, which we organized for second time in a row, called Event Horizon. This year it was in Berlin. 41 leading startups presented at the conference, and we surveyed them for areas of application. And again, peer-to-peer and distributed generation lead, but then there are also a number of other areas that are interesting. Although peer-to-peer is certainly the most transformative use of this technology, it is also one that will probably come last in terms of a wider application, because it requires legislative changes and a higher degree of scale than available today. But still there are applications in peer-to-peer that could be applied earlier. One example is a startup called Electron that helps people switch more easily from one provider to another, helps increase grid flexibility with more accurate near to real-time information and more use of local generation. This is a startup currently based in UK and doing a number of pilots in UK, but also looking at more global applications of what they do. Utility billing, not as simple as it seems, because there is settlement involved, alignment, especially if you combine it with peer-to-peer trading, where you may be selling excess energy from your electric vehicle or your solar panel on the roof to a neighbor, and then all of this needs to be billed in a different way. So EV charging is especially popular in Europe, but gaining ground globally. Share and Charge is probably the most famous startup here. One of the German utilities had invested in Share and Charge, and it is also operational in UK and Holland, and it will help on the distribution edge, so that not only you can use electricity more efficiently as a user of a car, but that you can also use your asset for other energy purposes. Demand response is getting very interesting, and there's a startup called FlexiDAO that has done some first pilots here, and as noted from the survey before, it is another area of interest. The startups that I have marked here are not the only companies that are working in the space in these various areas of operation. There is more. They just happen to be more advanced than others, and all of these are part of what we call the Energy Web Foundation ecosystem. and are relying on our common platform to get to market more quickly and at a faster scale. I do not expect you to learn this by heart, just to have an idea that there is some complexity as to how certificates of renewable energy production are issued today. It is also an expensive system where you have to go through a range of accreditation steps and then try to find a buyer. The buyer also does not always easily find a seller for the period where it needs the certificates. In some countries, this is this is compulsory. In most others, it's corporate social responsibility of companies who wish to buy certificates so they can offset the pollution that they are producing. And this, so if you compare, if you go back, and this is how it could work with the blockchain. This is not just a drawing. This is actually something that we already have in alpha phase. So as EWF Foundation, in addition to working on the platform, we decided to work on one app that will demonstrate that you don't have to wait for years for all of this talk about how useful blockchain could be to happen, but that you can actually start implementing it much sooner. And I will show you, so right now what we have done is that we have what we call a light client, basically a very simple connection to device. And this can be if you are, if the asset is a hydropower plant, it's connected to SCADA or whatever system the plant is using. If the device is your solar panel, it's something like a Raspberry Pi, a very simple connection. There is no specific limit as of yet in terms of the asset size. So imagine a world where it could be very simple, where you could go online or on your phone, pick an app. You may not even know that it's based on blockchain, and you will follow the instructions, connect your asset, and look for a buyer. And there will probably be a market where there will be someone aggregating smaller assets to buyers who want to buy more, just like there is in any market. But we will certainly have a lot more actors in this space. We will enlarge the market. We will simplify the market. We will make it less costly because there will be less intermediaries, less expensive certification, because with blockchain, you have near real-time authenticity of renewable energy that is produced, and then through something like what is called a smart contract online, you will actually have something close to a real contract where you sell those certificates to a certain buyer for a period of time where they need them at the price where you agree, which in some places is regulated, other places is not, but basically creating a much simpler and wider market with reduced costs. And this is something that now exists where we have a few pilots. We actually have 5. I will show you some. So Microsoft is buying certificates from a French, although globally also operating utility called Engie in 3 countries. We connected assets in 3 countries. E.ON, which is a large German utility, buying from TWF, which is a smaller utility, 5 medium-sized assets. We have a bank in Singapore buying assets from Singapore Power Group. We have our company, this is our office actually in the right bottom corner, buying assets from 2 developers. So those are pilots currently underway, they're real. The only difference between this and a real functioning app is that there is no easy interface as of yet. So that's something we're working on now. We're also talking to registries in different countries so they can change the way they register certificates. That is the only change that we need It is not actually a regulatory change, it is more an operational change of how registries work. And another application that we're working on, just to give you a bit of the taste of the future, and this will take more time, but we have now created a simulation environment where you can, where there is a bottom-up approach for devices in the home to be connected, and where, again, in the future, you'll be able to set your preferences so that, you know, if there is an issue, your fridge still works, or that you, your fridge negotiates where it buys the power from through a range of preferences that you put together, and that you connect your community in a microgrid. So that is the future. We now have just a simulation environment, but it's also interesting for utilities to use because they can plan investments in assets by putting this in a simulation and figuring out how this works out in terms of energy use pricing and transactions among them. What do we do at EWF? So as I said, we're a nonprofit. We're building an open source public blockchain. It's free. So anyone can use it. Anyone can put an application on it. And we have a test net that's been available from November 2017. And this is already transparent on our website. We have many supporters. So this is from 10th of June, but now I think we're close to 80. These are different corporations, startups, some venture funds that are in clean tech space that have contributed to the work of the Energy EWF Foundation, and that, especially on the energy side, we're working with through different work groups in different areas so they can learn and develop use cases and adopt the technology. Some are more advanced than others, but they really appreciate this peer learning. And they also realize that we need a single standard in energy. We need one platform, one app store rather than several, which is why they have opted to do this through the Energy EWF Foundation. So this is where we are. In IT world, when it's not blockchain, the actual operating system is not as important as with blockchain, where the core platform, the purple in the middle, is quite integral to the application. So we're building a platform for these applications to use and rely upon, but the features of the platform become very integral to the features of the app. The apps, some will be free, like the certificate of origin, which I noted. Some will be, you know, you will pay for them depending on the provider. Those are the providers. That's the market. The market is very competitive. We're just providing a platform for the market to develop. This is our timeline, and it's very technical. We're developing a range of features to make the platform as effective as possible. One more thing that I'd just like to note is that the way transactions are approved in the system is not mining. We do not consume a lot of energy. It's proof of authority. And it's a very interesting governance system that I can talk more about if there is interest in the Q&A session. And next year, we will have a launch, a final launch of the platform, which is also contingent upon integrating the governance structure and having the apps functional on the platform by sometime in 2019. That's a soft deadline, but by mid of next year, we hope to have a full launch of what is now a test net. So this is my email in case I don't get to answer all the questions, and happy to answer some right now.
Perfect. Anna, thank you very much. You must be Swiss. You hit it right at 18 minutes. For all of you who are attending, if you would like to submit a question, please do so by the chat function that you have in Zoom, and we will do our best to pull them together and present them to Anna. But for the meantime, we have a few questions here that we've prepared. One is just starting with the fundamentals, Anna. It seems like the important selling points for blockchain are privacy, security, and proof of contractual agreement. Is there something else? Is that approximately correct, or is there something else that is just as fundamental?
So privacy, yes, very important, but there are features that are now developed that can ensure that. So everyone can see that a transaction has happened, or a settlement or whatever is organized through what is called a smart contract, or basically a program automated process. But not everyone will be able to see the content of the transaction necessarily. There is also a very interesting feature whereby a regulator could have access and have real-time auditing of what is happening on the market. And scale is another issue where we have a range of technical areas that we're working on. I can go in more detail if there is interest, but the question here is not transactions per second, it's throughput per second. It's how much information you can push through, including, you know, how these transactions are approved and why. This is why right now you have a pilot in Brooklyn where you have you know, a part of the road connected. You have a pilot in Austria, in Australia, but you cannot as of yet connect the whole town.
Okay, thank you. You did mention at the end of your talk that you're using a consensus algorithm, which is proof of authority. The one that gets a lot of attention associated with Bitcoin.
No, actually quite the opposite. So Bitcoin uses mining. It's called proof of work,
right,
where you have to solve a difficult computational problem, and it requires a lot of power because you're using now not just your brain, you're actually using some computer equipment and hardware equipment. And so proof of authority is different. It relies on a consensus system of how transactions are approved. Mm-hmm. In the governance system that we're developing, we will have the affiliates who are responsible energy actors who will be providing oversight to the system, making sure that due process is followed. So they will be validating as validator nodes. For any changes, reforms in the system, those that are operating apps in the system will have the power to vote. So it will be a user-friendly governance mechanism. And it's not as simple as that, because we actually also have to integrate antitrust, data privacy regulation to the extent that's possible as a core platform. So we'll be more like what is internet is to the applications that are using it, rather than directly responsible for the compliance of every single application. So that compliance rests on the app side.
Okay, so that actually you anticipated the the end of my question, but I guess the lingering issue, which I think you probably have addressed, is compared to other consensus algorithms, how much energy does proof of authority require?
So not much at all, because authorities are essentially servers, nodes that are connected to the network. And for the way we envisage the system is that we would like to have at least 100 such connections, because there is democracy in numbers and ensuring that there is protection of competition, and that no one is misusing the technology to have an unfair share of the market. So that is very little energy use altogether. But it does bring added complexity in that you have to actually devise a mechanism of how these authorities then make decisions, because it's not based on this computational work.
Okay, that's helpful. Thank you very much. There's a question here on risks of blockchain. What if something goes wrong? Are there technical risks, commercial risks, personal risks, and is there a risk of a fake blockchain that could intercede and be perpetrated by say, criminals or others?
Yes. Well, there is a range of risks in everything that you do. We have a full page of what could happen, right? But overall, those risks in terms of security are much lower than with other options when you want to automate and use IT. There are risks related to the fact that this technology is still at research stage and that we may not be aware of some of the problems they may turn up. So we've had cases in the past where, you know, people's private keys were stolen, and therefore, although something was super secure, they could still, you know, enter and use the data. So that was dealt in a certain way. We had cases where in one blockchain project, a lot of money was stolen. That money was taken back. We learned from the bugs and problems in the system. Those were solved. We had cases where someone deleted the library and froze access to someone's account. So we've had issues with blockchain, not in energy, but just overall blockchain development. And as you innovate, you make mistakes and you learn. So those now are resolved, but as I said, we are not aware of what may happen in the future.
Okay, that's helpful. Along those lines, what kinds of obstacles do you encounter in convincing retail customers to adopt what you offer or blockchain in general?
So we're still offering learning. We are offering a platform that they can test and use. Some energy actors espouse it, are thrilled that they can be part of the community and that they can foster innovation in their own community. Even though not all are necessarily ready or have an application that they're certain they want to use, but they want to be part of the learning. Others are in wait and see mode and would maybe join in a year. I think it's very typical as for any emerging technology. And just to make sure there's full clarity and security, I would just like to add to the previous question that at the moment, blockchain-based database is the most secure database or system that exists. And the security problems are related to the access the way they're related to any IT solution. It's at the access point where the human dimension that will always be there. Okay,
thank you. That's a good clarification. And maybe one final question, Anna. When companies turn you down, rather than agreeing to become an affiliate, what reasons do they give? I mean, the list of affiliates that you have in EWF are quite impressive. You've got some major incumbents like Shell and Duke Energy and other smaller players. But what were the kinds of reasons that they present to you when they turn you down?
Well, simply as I noted, that they want to see how the technology evolves and join later. There wasn't anyone that was necessarily against the technology. I think that right now all see the potential. It is just that not all have, you know, based on their other commitments, the time and resources, people that they can devote to contribute more to the project.
Okay. Anna, thank you very much for an enlightening presentation and discussion. For everyone online here, the recording of this session will be posted on our website within about 24 hours. And let me announce that we would be thrilled to have you join us for our next Business and Energy Talk with Nick Gogarty, who is the co-founder of SolarCoin. And that will be at the same time, 11:30 a.m. New York time, or 17 hours 30 Central Continental European time, on the 26th of September, a Wednesday. If you happen to have any comments or suggestions about our talks and have ideas for future talks, please let us know. You can respond to our broadcast email or directly to either Dave Nagel or to me, or to both of us. But for now, thank you for joining us today. Until next time, we wish you a very pleasant summer. Bye for now.